I'm Nicholas, and I'm here today to talk a bit about AI agents and especially how you can empower your AI agents, how you can scale them with tools like a file system or a bash. But a bit about myself. I'm Nicholas. I studied here in Munich at the TUM. I studied computer science. I was in consulting after that for 2 years. I built lots of AI agents for different companies in different industries. And since half a year, I joined a startup called Superglue here in Munich. We're an AI native integration platform. That means we have as a main piece of our product an AI agent that helps you understand your system landscape and helps you build and maintain integrations. So I've built agents for the last 3 years. I've seen them evolve from basic chatbots to really like conversational partners that have capabilities that help me in my day-to-day life every single day, be it like Cursor, Cloud Code, or also like other chatbots and apps. Like if I'm doing an insurance or something, I always love the chatbots on the websites and stuff. So I see that they are evolving, and I'm today love to talk a bit about the future of them and where I see what we're still doing wrong, what we could do better, and how we could empower them to reach the next level of efficiency. But before I do that, at the ground of every AI agent, there's the LLM. And I'd love to get a sense of the audience today, of you guys here, where you think the state of LLMs is currently. Like, how good are they actually, and how much do you trust them? Let's say you have a task, and you give it to an LLM. You have a task. Who are you handing it to? And I have 4 options here. I have the intern, the junior engineer, the senior engineer, and the staff engineer. And I'd love to do a little show of hands, how you think, how much you trust it, how you think the capabilities are. Who thinks if they have a task, they give it to the intern of the team? All right, a couple people. Who thinks it's more like the junior engineer? A bit more. Senior engineer? And who says it's actually like I'm learning from the LLM, it's a staff engineer, and I like to make the decisions? All right, a couple of you. I think that looks great. I think it was mostly juniors, some seniors. And I feel like that's about the way I feel as well. And maybe this is the crowd here is a bit more LLM enthusiastic. Maybe it's a bit above the average engineer. But I think that's great because LLMs have evolved so much in the last couple of months, years, like with Opus 4.6 coming out, the things it does, it's just crazy. And I think that we all know how good they are, but we don't implement them in a way how a senior engineer would. Like, we don't trust the agents like we trust the senior engineer. And in this talk today, I'd love to go a bit into this topic about how I see AI agents being implemented as if they were interns. Let's look at a specific task and illustrate this example. So let's say you're at a company. You build an AI agent, an internal chatbot. I think lots of us have done this already. And then a request comes in. Hey, I want our chatbot to read a CSV and write it to a database. Can you please implement this? Can you add this capability to our chatbot? Because, I don't know, some team has some CSVs that needs to be uploaded into a database. And I, as an engineer, or we as an engineer, we need to implement this. And what do? We give the LLM, which is actually just like text-based, we give the LLM tools it can call to interact with systems in our world. And I think it's a fair assumption, and I've seen this in lots of practices. Let's add a couple of tools. Let's add a read file tool. We can look at the CSV, we can see the structure, we can see the columns it has. Let's look at a get database schema. Let's add that tool as well. We get the schema, we see if they match, we see if we can just like insert it or if we need to do some transformation. And if we need to do some transformations, we'll just add an execute Python code tool. 3 simple tools. I think the LLM should handle this. It knows how to use the tools. It knows how to write Python code, and we add those tools to our agent, and now it can read a CSV and write it to database. But then we noticed that actually it's a bit more complicated than that, because like the CSV those people use, they are semicolon separated. We might need to add a delimiter to our tool call as an additional optional parameter. Actually, we have a client from China. If they have Chinese characters in the CSV, it's differently encoded. We might need to add an encoding. And I know that one team uses like 2 GB CSV that will blow up our context window. Let's add like a max rows. And we add lots of other stuff in those tool calls. We do the same for the database schema. We need tables from a different schema. We do the same for Python tool execution. We need to add a timeout and that stuff. And then we think, actually, we saw the logs and we saw that somebody said, hey, can you upload this CSV, but didn't specify the table. We might need to add a tool that lists all available table in database. And you see where I'm going with this. Like, we need a rollback tool because somebody uploaded an old old CSV actually was the wrong one. He didn't want that in the database. He wants a new one in the database. We need to roll that back. Maybe a CSV with some faulty rows and that stuff. So we are at a place where we add so many tools and so many optional parameters that our context that the LLM gets when we ask the question is already filled. Like, the moment the LLM really starts working on the task the user said it has already gotten, what is that, 50,000 tokens of just like JSON schemas. Like, every new tool, every new optional parameter is tokens that we give the LLM. And it is, we know that LLM responses are correlated to how good your context management is, like the accuracy and the value of the response. And if we, if we load all our context with stuff that we actually don't need for this specific answer, we might need the rollback on failure tool on specific tasks, but not on all of them. Then our answers overall deteriorate. This is a problem. And I've seen a lot of agents need to deal with this. What is a solution to this? And I think I boiled it down into one simple sentence, and that is stop making decisions for the agent. It sounds simple, but treat your agent like a senior engineer. Don't treat it like an intern. The tools we added in our previous example are pretty much what you would give an intern if you give him the task. Let's say you have a real life, like a human intern, and you want them to upload a CSV into a database. You might download the CSV yourself, send it via Slack. Then you might take a screenshot of the database structure and send it to them via Slack as well. You might tell them, hey, use this IDE, use this programming language, we use this code style. You basically micromanage. You wouldn't do that to a senior engineer. You would give them a laptop, you would give them a terminal, give them a goal, maybe the path to the Python file, and then database credentials. And the rest they should figure out themselves. And we don't do this with agents, but I think we should. We should give our agents tools that let it think for itself, that enables them to follow their own path, not the path that we predetermined for them. In the case of our task, like writing a CSV to a database, this could be a bash tool. It doesn't have to be, but let's say we give our agent just a simple terminal tool with a little file system setup. What would it do? It could call head-5data.csv to get the CSV structure. It could call file.data to see the encoding of the file. It could do a PSQL command to see the structure of a table. It can do a Python transform by to like transform the data, but it doesn't have to be Python. It can do JavaScript or any other language as well. It can do the things that are necessary for the task at hand, and we don't predetermine what exactly it should do, but it's more like it figures it out itself. It does all those things, even though we haven't told it how to do it. And that is because LLMs are already very smart and they know how to handle terminals. They know how to code because that was in their training data. And they are especially like Codex, or for example, is trained to do this. Like that's the way they, that's the way, the best thing they can do. And calling tools, they can also do that, but they're not as good as coding. So if there's like 10 different tools they have to choose from, it's harder for them than just calling one single tool with like different terminal commands. So yeah, it's one tool, except instead of 6, way less JSON schema polluting our context window on every call, and also way less maintenance, because we don't need to handle edge cases. We don't need to handle like fallbacks or something. The agent just does the terminal command. It sees the output. If the terminal command fails, if there's an error, it reads the output, it self-adjusts and something like this. So LLMs already know how to talk to tools like a terminal, and we don't have to explain them how to do it, and that's why our system prompt is also way shorter. So yeah, this is a bit of what I'm like thinking the future could look like, and you might be saying, hey, this is pretty cool. I've seen this used, or actually who uses this, and I'd love to take a look at this in practice. Who actually does something like this? And I want to be clear. I'm not saying you should give your agent a terminal with like full access or something. It's more about the mindset. It's less about the technology and more about the philosophy. Like, stop packaging the answer and start letting the agent find it. I think looking at other companies and projects they do is a great way of seeing that. And I interviewed some people at companies. I read a lot of engineering blogs and looked at open source repos, and also my own practice with our startup and our agent. And I've composed or compiled 4 industry stories for us to look at how different companies handle this. So there's AWS, also present in the room, how they use agents, how their agents use CLIs, which is pretty cool. We have Vercel, whose agents use SQL. I have a pretty cool example of Anthropic, how they built something where their agents actually walk through file systems, and then I very cleverly added our little startup next to those cool names, and we've been on this journey as well. And our agent has gotten significantly better every time we stepped away and let it do more freely. And yeah, it uses skills now, and I want to talk a bit about what this means for us and the use cases we follow. So yeah, let's jump into the AWS example. So I don't know if you've been on AWS lately, but I think there's a pretty cool new feature. I don't know when it dropped, but I love to use Amazon Q. I don't know if you notice. It's on the top left. You click, and it's a pretty typical AI chatbot. You can chat with it about your resources, about your configuration, or it helps you set up stuff. And for me, that's pretty good because I don't think AWS is the most intuitive piece of software. This is what it looks like. It's pretty simple. I asked it, hey, what are the permissions of my identity provider? What did it do? It answered me. It looked at some resources. It gathered some context, and then it looked at some more resources. And I asked myself, like, hey, how is it doing that? And it turns out, it's not a surprise, it's in the title of the slide, but it's using the AWS CLI. And this is such an easy and cool complex concept for me, at least, because it makes so much sense, especially given the scale of AWS. Let's say you had to build a chatbot that needs to be able to handle all the different resources AWS has with all the optional parameters, let's say like region, sub-ID, resource filters and everything. Like, you would, first of all, not like have to code a lot of tools and a lot of different optional parameters and stuff like this. And you would pollute the context with so many different tool calls and options. But having like one tool, which is the AWS CLI, makes so much sense, and it's so easy. So let's look at what this actually means. So in our case, I don't know, I can't look behind the curls, but I guess it used AWS list identity providers to find all my identity providers, then saw the ones I mentioned with my name, and then did some more calls to find out what I wanted. Amazon Q, of course, has a lot of things it can do, but the main part is the CLI, and it's super easy for an LLM to call the CLI without the developers having to add a lot of system prompts, because the AWS CLI is very big. It's an established piece of software, and its documentation and the Stack Overflow questions of it are probably in the training data of the LLM itself. So it just makes sense to use an established application interface for a product and not rebuild a new one just for your agent. So yeah, there's data in the models. The models already know how to use the AWS CLI. And what is pretty cool about the CLI, and this doesn't mean you can only do this with like big CLIs, which already know like AWS, but CLIs are self-documenting. So even though you give the agent, let's say, a super new CLI it has never seen, there are still standards that apply. The agent would expect that you can call the -- help command to see all the commands that a CLI has output, and it can walk through that, and it doesn't need to see like, hey, those are all possible options. It looks at specific subcommands and looks like, hey, for this subcommand, what are the possible options? And thereby it fills its context with the relevant information without having too much information, like about all the resources and all the possible options. So CLIs are a way of the agent to go deep into multiple possible options of capabilities it has, and then get documentation information about a specific thing before making the actual call. I don't think that AWS gave Amazon Q a terminal with hey, execute the CLI command. It's more like a tool which gets a CLI command and then probably calls the API or something. It's not about the technology, like I said. It's about thinking, how would I do this as a developer? How would a senior engineer do the task that the human behind the agent wants us to do? And then thinking about how can I implement in my agent something that is similar. So yeah, this was AWS. I think this is a pretty cool implementation. It makes a lot of sense. Let's look at the next one. It's Vercel. I don't know if you know Vercel, but they're the company behind Next.js and the AI SDK, AI Gateway. So they're pretty familiar with AI agents. And they have a tool called D0. It's an internal data analytics agent. So it sits in Slack. You can see a screenshot down there. You ask it a question, and it sits on top of your analytical database, and it can query information and answer to you. How did the Vercel team build their tool, build the agent? Actually, they were very clever about it. They did a good job. They first set up a testing data set of questions and answers that should come out, and tables that should have been used to get those answers. And then they built a super simple agent, ran it on a test set, and saw what answers it got wrong, and then added tools and capabilities to make sure that the next time it would run, it wouldn't get those answers wrong. This led to, and I'm jumping ahead a bit here, the agent having 17 different tools. Now, if you can see this, those are the real tools that the agent had at one point. You can see, for example, the get entity joins is there because it happens that the agent would fuck up joins of different tables. You have a search catalog because it would forget hallucinate table names and all that stuff. And then they added new tools. They added a lot of guardrails. They didn't trust their agent to make decisions because they thought it was making a lot of mistakes. Every single tool or thing they added pushed the benchmark of their test set from 75 to 76 to 78%. But they plateaued at 80% good answers. And they thought hey, how can we get this to 100? What are we doing wrong? And then one day they said, let's kill all of the tools, remove every single one of them, and just keep the execute SQL tool. Remove all of the other ones and just keep the execute SQL tool and give it our database schema, the cube.dsl file, and see how it does. The results were a bit embarrassing, but it worked way better than before. And so here I have a bit of a data, and we can go in this, 17 tools before, one tool afterwards. Super easy to maintain. You don't have to explain in a system prompt when to use which tool or something. Way easier to maintain. We went from a 274-second average response time down to a 70-second average response time, so time to results 3 times faster. 37% fewer token use per query, and the most important factor, 99% success rate. This is odd. You don't have the guardrails, you don't have the system prompt to explain exactly what your tables do, and still the success rate is so much higher. And the only real explanation for this is that the LLM is way better at doing tasks when it has less context pollution by just a lot of tool definitions, a lot of JSON schemas, and just has a higher percentage of the prompt is related to the task at hand it needs to solve. Again, here, the key takeaway is not that they let their agent use SQL. They trusted their agent. They let it figure out on its own. Of course, it made mistakes and SQL commands failed, but it could read the results and it could do a new one. You don't have to guardrail everything and catch failures. If the syntax is wrong with the SQL earlier and have a special tool to check the syntax, It's okay if the command fails, and the agent will understand, it will expect it, it will know what this failure means because it has been trained on this data. So yeah, also here I don't think Vercel gave their agent a terminal. I think it's more like a tool where it gets an SQL, and then this SQL has probably credentials to read only and maybe get security checked before. This is not about a terminal, it's about trusting the agent and empowering it. Next one is Anthropic and their file systems. So this is a pretty interesting case, I think, and this comes from an Anthropic engineering blog. They worked together with a customer of theirs who had to build a customer support agent. And I think customer support agents are maybe one of the biggest applications of AI agents currently. And traditionally, if you want to get customer information for the call, you have a tool. Let's say either you have a tool that says like, hey, get me customer information for this customer ID, or you pre-fill the system prompt with information on that customer so that the agent, when it gets a ticket, when it talks to the customer, it has all the information it needs from like profile summary to previous tickets to all of that stuff. But this JSON or this data of the customer that we pre-fill or that we get from the tool is often overfetching or underfetching. It's often overfetching because it returns us like the previous 5 tickets the customer opened, but maybe the new question the customer asked has nothing to do with the previous tickets. Or it's underfetching because it doesn't want to return 100,000 characters, but actually the logs and the error stack trace of this one thing that failed for this customer would be super important to resolve this issue. So how did Anthropic solve this? They gave the agent a file system. Every single customer got a folder. Inside of that folder, they got a ticket history, they got their usage logs, they got their profile summary, they got error stack traces. And when the agent gets a task, it gets dropped into the file system and just goes freely. So it has navigation. It uses ls and cd to go through the folders and look, hey, what's there? It uses cats and grabs, for example, if it's interested in billing information. It goes into, what's this? For this one, for example, it would do a grab on like billing or subscription on a specific file and only get like the parts of the file that are relevant for the task it needs to solve. By letting the agent navigate the file tree, Anthropic reduced the engineering because there's only one tool, right? And the agent became significantly more precise because it could fill its own context with only the data it needed to answer this specific question the customer has. I think you see the common path with all of those examples. But exploring data this way is more natural and closer to how we would do it, and that's why maybe agents should also do it this way. Lastly, I'm going to talk about superglue. I briefly mentioned it, but we have an AI agent in our product, and it helps you build and maintain integrations and workflows. It does a lot more than this, but for this talk, I want to specify and look at only the workflow building capabilities. So what does this mean? Like if a user comes to our platform and he says like, hey, can you create a sync between my Salesforce and my Snowflake that runs daily or something? Our agent should be able to do this. It should be able to call the Salesforce API to do a data transformation and then upsert into Snowflake and something like this. So this is what we call a workflow, and it should be able to do this, to build this. How does it do this? We've been on a journey here a bit, and I want to show you 3 stages of our agents, which we went through, and a bit on why we changed it up. So maybe the first version, it's a V1. We call it the context micromanage version. And this is the user comes on our platform. It says like, hey, I want to sync my Snowflake with my Salesforce. The agent has 2 tools, a build workflow and a save workflow. It maybe does some question back and forth, it gets some more information, and then it passes a prompt into the build workflow. And in our backend, we do a lot of stuff. We build what we thought were the perfect prompt. We filled the prompt with exactly like 25% documentation from Salesforce, 25% documentation from the Snowflake API. We added a bit of context about what we know about this customer. We added, how do you build workflows on superglue? What are edge cases? We know Salesforce uses OAuth2, so we added a part about OAuth2. We built the perfect prompt and sent it away and got a workflow back. And I mean, it worked, but as you have noticed by this talk already, it was way too predetermined. Like, we thought we knew exactly what the customer or the agent wants, and this was not the case. What did we do? Version 2. We call this the context gathering jungle. We thought, like, yes, actually, we don't exactly know how the prompt should look like, but the agent might know how the prompt should look like. So let the agent search everything. We gave the agent a search documentation tool. We gave the agent a search web tool, a clarify intent, and a lot more tools. Actually, I think it was like 10 or 11 in total. And with those, it would do all the tool calls. It would ask a lot of questions. It would have all the information it needs. It would build this perfect prompt, what we thought, itself, and would send this prompt to the backend, and we would then in the backend do the workflow building, validation, and then run it back to the front end. This worked better, but we overdid it again. The tool definitions were huge. After every tool call, we send over like an hey, I think next you should actually call this tool because you might need some more information from there. We had fragmented system prompts everywhere and just a whole lot of context below it. And the agent had to deal with the decision, which of those 13 tools do I call every time, which ones do I call first and something. So again, we did the thinking for the model. And we quickly saw that this was not the perfect solution. So what did we do in version 3, which is the current version? We're pretty happy with it. We said we want to reduce the context and the system prompt length and the tool definitions by a lot. So we didn't remove a lot of tools. Like, we still have the search web, we still have the search documentation tool somewhere, but we added skills. So we took a lot of our system prompt, we took a lot of the tool definitions, like the detailed tool definitions, and put them into skills files. Skills files are markdown files that live in one folder. We have about 20 of them, and we give the agent access to look up the skills it needs for this task. So the system prompt got, I think, reduced by like 80% or something. And now the agent, when it gets a question, it thinks like, hey, what do I need to do to answer this question? What skills, what knowledge do I need? And it looks up this knowledge and this skills in those markdown files. And then with this knowledge and skills, it then does some web search, some maybe documentation search, and then it builds the workflow directly in the conversation. So we took out the break of the agent, which went to the backend, and we built the workflow in the backend. We said the agent should build the workflow directly in there because it now has all the knowledge. We have now a huge skills.md file which explains how to build workflows in superglue, how the JSON structure, how our data structure looks like, how our quirks and edge cases are, and it has the tools to test the workflow. It has pretty much everything it needs to be able to build the workflows itself. And this turned out great. It is such an improvement in quality. I don't have specific numbers here, unfortunately, but we've seen that the tools we are building are way complex now than they were like a couple of months ago, and that we have way higher success rates. And this not only helps in tool building or workflow building, this helps in like so many different areas. For example, if a user comes to our agent and their intent is not to build a workflow, their intent is just to figure out what's superglue's pricing, we had to have a section for that in our system prompt before that says like, hey, actually check out this URL to see information about superglue, or actually we do support SAP because a lot of people ask us that or something like this. And now we have a dedicated skills file for that, and the agent can just look that up, but it's not ingested every single time you ask a question. It's not polluting the context. So yeah, this is the version we are currently at. There might be a V4 soon. I don't know. We do have to do some iteration, but what I can say is that last week we launched the superglue CLI, and we are currently exploring how you would copy documentation of different systems into a file tree. So I think there's a lot of exploring to do, and not all solutions fit all agents. It depends on how many different tool calls you have, how many parameters, and how you want to display your tool calls, and all of those stuff. But I think there's always improvements, and you can always look at your tools and your agents and think, how would I solve this? How would I go about it? And then yeah, try it out and see if it works better. I think I can come to the conclusion now. There are 3 points I want to come back to again from the start. I think agents are senior engineers. They're not interns. LLMs have evolved. We need to treat them that way. Empower your agents. Don't think for them. They're actually pretty smart. They can make the decisions. And last one is a bit of maybe a different topic, but if you have a company and you have a product and you want your agent to, you want not only your agent, like any agent to use it, I think you should build a CLI. I think this is going to be the future. A lot of agents will use it. We saw it with OpenClaw, for example, that you can just install skills or something, which is basically a CLI, and people want this. People want to interact in a way with your product. So yeah, that's a conclusion. Thank you very much. And yeah, superglue is hiring if you need it.